welcome to True Projects. In this video, we are going to discuss about the project which is rainfall prediction using machine learning and deep learning. So, before getting into the execution, let us understand what is the project about. Rainfall prediction. It plays a very important role in everybody's lives. Mainly, it is very important in agricultural sector because if the farmer know when will it rain, then only he will plan when to plant their crops and when to water them. And this ensures efficient water usage and it helps preventing crop damage from drought or excessive rainfall. Moving on, it is also important for water resource management because if they know when will it rain, they can ensure a steady water supply for drinking and also for irrigation and for other purposes. And it is also important for disaster preparedness. Early warnings based on rainfall forecasts are essential. They enable authorities to evacuate people from flood prone areas and they mobilize emergency response teams and implement measures to mitigate the impact of natural disasters like floods and landslides. Additionally, rainfall prediction is important for urban planning because it relies on rainfall data to design infrastructure for drainage systems and flood barriers. So, in this project, we are going to develop an efficient system that will accurately detect rainfall. Logistic regression, it was the existing method that is used for predicting the rainfall, but it had some limitations. And that are logistic regression, it has the assumption that it works only well when the data is linear. But when the data is non-linear, it doesn't work well. And it is also sensitive to the data quality issues. And it cannot adapt to changes in the climate dynamics. So to overcome those limitations, in the base paper, the author has proposed specifically RNN, that is recurrent neural network. It is a deep learning model. Recurrent neural network, it first processes the sequential weather data by maintaining an internal memory of past observations, and that allows them to learn temporal patterns in rainfall data. During training, RNNs learn to map historical weather sequences to corresponding rainfall values, enabling them to make predictions on future rainfall based on learning patterns. Furthermore, to improve the performance, we have employed the ensemble method, that is voting classifier. It combines both the decision tree and random forest to make the accurate prediction of rainfall. And we have evaluated all the models built in the project using accuracy, precision, recall, and F1 score. By doing so, this project will benefit farmers, water resource managers, disaster management. Moving on, to implement this project, we need software and hardware requirements. Coming to software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3. Front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. Coming to hardware requirements, we need operating system of Windows, processor of i5 and above, 8 GB and above RAM, 25 GB and above hard disk. These are the models built in the project, that are voting classifier, boosting, bagging classifier, random forest, support vector machine, and RN. Along with voting classifier, we also built the other models to compare how well the proposed model is performing well than the other models. So let us understand what is this voting classifier. Voting classifier is an ensemble learning technique where predictions from multiple individual models are combined to make a final prediction. Here, we have combined decision trees and random forest, where each model generates its rainfall prediction based on the input data. And the voting classifier, it aggregates these predictions based on a majority vote or a weighted combination of these individual predictions to make a final decision. By leveraging the collective intelligence of multiple models, the voting classifier, it aims to enhance the accuracy and robustness of rainfall predictions, potentially outperforming any single model alone. So now we will execute the project. To execute it, first we have to open the code folder that contains source code files. So this is the code folder of the project. Let us understand how each file will be used in the project. So the first folder is static folder. This folder contains files related to CSS, JavaScript, and Bootstrap files. These files, they are important for project styling and interactivity. Moving on, templates folder. Here lies all the HTML pages utilized in the project. And the HTML files are index.html, about.html, etc. And each HTML file represents the different pages of the website and provides the structure and layout for displaying content to the users. The next file is the app.py file. This Python file encompasses the front-end logic of the project. It handles server-side operations, including processing user requests, interacting with the database, and dynamically generating content to be presented in the HTML templates. This is the model file. Here is also the model file. These files contain the algorithm information, and that will be loaded into the project code during runtime. The next file is a notebook.ipynb. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. So this is the signup.db file. This file is a database file which is used to store the user information. And in this file, we have the data set which is used in the project. This is the data set related to rainfall. So these are the parameters which are important for predicting the rainfall. And the parameters are pressure, maximum temperature, temperature, minimum temperature, dew point, humidity, cloud, sunshine, wind direction, and wind speed. So based on these parameters, we will be predicting the rainfall. So here is the target variable, that is it will rain or not rain. First, in the code, we load this data set and then we pre-process it. After pre-processing, here is the data set that is used for training the models. And here are the extracted important features from all the features. So these features impact the rainfall, whether it will rain or not rain. So close this. In the sample folder, we have test cases that will be used for predicting the rainfall in the front end. So close this. Now we need to copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now we need to open the Anaconda prompt. Using the command cd followed by the space, we need to paste the copied path and now click on enter. So here we can observe that current directory is changed to the code folder's path. Now we need to compile app.py file. So give the command python space app.py and now click on enter. This command will execute Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, Flash framework will host the application locally at the default address, which is localhost and the port unless configured differently. So now we need to copy this local link provided by the framework and paste it in any web browser. I prefer Google Chrome, so I'll paste it in that. Here we need to paste the link and then click on enter. This is web page of the project and this is displayed in the browser. And this web page is developed using Flash framework. So now first we need to sign up. So click on sign up link and enter all the registration details if you are registering newly. I have already registered and I have an account in it. So I'll directly log in. So click on I am already a member. And here we need to provide the credentials, which are the username and the password. So I'm giving my username and the password. Now click on login. We have logged in successfully and we are redirected to prediction page. Before entering the parameters, first let us understand them. The first one is pressure. It is nothing but it is atmospheric pressure which can influence weather patterns and precipitation. Moving on to the max temperature, it is nothing but it is maximum temperature recorded during a specific period affecting the amount of moisture in the air and potential for rainfall. Dew point. Dew point is nothing but it is a temperature at which air becomes saturated with moisture, indicating the likelihood of the precipitation. The next one is humidity. It is the amount of water vapor in the air influencing the likelihood and intensity of the rainfall. The next two are cloud and the sunshine. So here we have the cloud and sunshine. The last one is wind speed. It is nothing but it is the speed at which air moves affecting the distribution of moisture and weather systems, thus influencing rainfall patterns. As we have understood all the parameters, we will enter them. Here in the sample folder, we have the test cases. So we will copy those test cases here. But it is the speed at which air moves affecting the distribution of moisture and weather systems, thus influencing rainfall patterns. As we have understood all the parameters, we will enter them. Here in the sample folder, we have the test cases. So we will copy those test cases here. So we will try predicting the rainfall using the first test case. So the pressure is 1005, maximum temperature is 31.5, dew point is 26.7, humidity is 84, cloud is 90, sunshine is 1.3, and the wind speed is 24.3. We have entered all the test cases. Now let's click on predict. So based on the provided parameters, here we got the prediction that there will be rainfall based on the weather condition. So now we'll try giving some more parameters, some more other set of parameters. So click on home. So now we'll try giving this test case. So the pressure is 1032.6. Coming to the maximum temperature, it is 10.8. Dew point is 3.7. Humidity is 46. Cloud is 25. Sunshine is 10.1. Wind speed is 28.7. So now click on predict. Here we got the prediction that there will be no rainfall based on weather conditions. So based on the given parameters, it is predicted that there will be no rainfall. So now we'll try giving some more set of parameters. This time we'll be try using this test case. So I'm going to copy the pressure. Coming to the maximum temperature, it is 18.9. Dew point is 16.8. Humidity is 95. Also the cloud is 95. Coming to sunshine, it is 0. So there is no sunshine. Wind speed is 35.1. So now click on predict. Here we got the prediction that there will be rainfall based on the weather conditions. That means it will be rain based on the given parameters. Now we will try giving some more parameters. So click on home. This time we'll be giving this test case. So the pressure is 1012. Coming to the maximum temperature, it is 31.2. Dew point is 23. Humidity is 74. Cloud is 44. Sunshine is 10.1. Coming to the wind speed, it is 26.2. Here we have entered all the parameters. Now click on predict. So based on the provided parameters, here we got the prediction that it will be raining. So now we will give other set of parameters and predict the rainfall. Click on home. Now we will try predicting this test case. So here the pressure is 1006. Coming to the maximum temperature, it is 32.8. Dew point is 20.6. Humidity is 61. Cloud value is 30. Sunshine is 11.1. Coming to the wind speed, it is 16.4. And now click on predict. So here we got the prediction that there will be no rainfall based on weather conditions. So now we will see the comparison graphs of the project. Click on About link.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.